Jai Hind students, and this is the second lecture, the Network Congestion Control Algorithm. In the first lecture, we have studied the cause of the algorithm and basic principle about the algorithm, how to algorithm occur, what is the region which contribute in making the congestion, and we also study the how to prevent them, or there is a two type of the solution. One is open loop and another is the closed loop. Then open loop is basically we have the take the corrective actions, and closed loop we take the in the closed loop we study after the how to remove the congestion when the congestion already occurred. But in open loop you have know that there is some retransmission policy, acknowledgement policy, discard policy, and virtual path, and in closed loop we have studied about the back pressure, choke packet, implicit signaling, explicit signaling. So these are the solutions. So how we implement? Now we study the how to implement this removing the network congestion control algorithm. There are the two algorithms. One is the leaky bucket algorithm and second is the token bucket algorithm. Leaky bucket algorithm means it is a traffic shaping mechanism that control the amount and rate of the traffic sent to the network. Leaky bucket algorithm shape burst traffic into the fixed traffic by averaging the data rate. You can understand in the real time example. This is just like a tape and there is a bucket. So this bucket from the water is coming from the tape is the burst flow. What is the mean by the burst flow? Burst flow means the rate of the water coming into the bucket is not fixed. Sometimes it is very fast, sometimes it is slow, or it may be happen that sometime we have not opened the tap. So you can say one thing important, that this is a inconsistent flow of the water, and taking this scenario we call it burst flow. This is the input. And what happen if we give a one hole in the bucket, one or two hole? What are the hole we can take? So you can understand that flow of the water from this is almost same. flow of the water from the same. It means if the bucket is full, the flow of the water from these hose, from that hose are fixed if all the holes are in the same river also, somehow. And you can, and this principle is working similarly in the packet. So we provide it is a constant flow. We can't control the thing, the input flow, but using this bucket, we can control the output flow. Means fixed flow will come down. So this is the concept of the leaky bucket algorithm. So what we have told you, what's being with the example, the rate at which the water is poured into the bucket is not fixed and can be vary. It leak from the bucket at the constant, but from the hole which is given in the bottom of the bucket, leak, well, water is leaking from that bucket is the constant. Thus, as long as the water is present in the bucket, rate at which the water leak does not depend on the rate at which the water in input of the bucket. This is clear. What rate? Whether water is heavy flow into the bucket or slow flow or even ideal, it is not coming in the water, but bucket is full of the water, then the you can say rate at which the water coming out from the hole is not depend on these things. It means the water is coming out from the hole is the constant when the bucket is full of the water. Yeah, if full not, you can have the water in this bucket. And when the bucket is full, what happens? Additional water that enter into the bucket is spill out over the side of and lost. You can say if water is continuously flow, then it will out from the side. So in this way, the same concept can be applied to the packet in the network. The same way we can apply the packet in the same way. So you can say as soon number of the packet dumped into the subnet by the host is within the carrying capacity are delivered. At this stage, the number of the packet delivered is proportional to the number of the packets sent to, and no congestion is take place. As the traffic increase so far, router no longer be able to cope up the loss of the packet, and further traffic performance degrade and very high traffic performance follows this. Then leaky bucket concept come this is so I told you the network congestion came earlier. I told how do the network congestion come. This is the way the network congestion came, but we can control this congestion using the leaky bucket algorithm. You can say the packet, the way we are showing, these are the packet, 3 packets are coming. In between 2, there is an ideal time, there is a no packet in this way, and then after the ideal, some packet are coming, and these buckets hold the packets, and this whole regulate the packet. It means consider a data is coming from the source in variable speed. Suppose you can understand the way you can, I take the example for, suppose there is a source and a data at 12 Mbps for the second. You can say this data for 4 seconds we have sent, and there is a no data for the 3 seconds, means in this between there is a no data, and then the source again transmit the data at the rate of 10 Mbps for the 2 seconds. The total data is sent is 4 plus 3 plus 2. 4 plus 3 plus 2. Then 4 seconds we have sent the data for 12 Mbps. For 3 seconds there is no data. For 2 seconds we send the data for 10 Mbps. So how much time we utilize? 4 is 9 seconds, and total data how? 12 into 4 48, and 2 into 10 20. Then total amount of data is 68 Mbps. But if leaky bucket algorithm is used, so data flow will be 8 Mbps for the 9 seconds. Matlab, for whole this data here in last, the data is coming out 8 Mbps per second. Means total data for 9 seconds, how much data may be come out? 8 into 9, 72. This is constant flow. So you can say 8 Mbps, 9 into 8, 72 Mbps data is coming out. So you can understand that we are getting the data out from at the fixed rate. And so how this implemented? So each host, you can say each host is connected to the network interface containing the leaky bucket. And which principle it is work? First in, first out. Means you can say which packet, if there is a first in, first out, means if these two packet is coming, these two packet are coming, this one and this one, so first in, first out. If there is a packet, here is the another packet, and this one. So this packet is come out, then this one. After that, that packet is come out. First in, first out. That is the reason. First in, first out. It means, and if packet arrive in the queue, when queue is filled, the packet is discarded naturally. Just like the bucket is full, the water is out from the side. In this way, if the packet is arrive at the queue and when it is full, then it will be different. So it uses the clock tick for packet from first in, first queue. Well, how it will find out? So it means the clock click. After every second, if there is a packet size is the same, so every click, after every 1 second, there is a one packet is out. It is fixed that every packet, one packet is out, but at the input end, there is not fixed. Every click, maybe the 3 packet is in, 10 packet is in, it may be, input is variable, but output is constant. We can say at every click, one packet is out, or in the manner first in, first out. And another case, if packet size is fixed, then we can use the click one packet. If it may be a variable size, then we use the packet size. We fix up the byte. For example, every tick, every single tick, we find that 1024 bytes are out. If there is a two packet, if there is a packet size is 512 byte, then the every tick, how many packet is out? 2 packet. Because our size is fixed of 10024. If packet size is 256, so how many packet per tick come out? Is 4 packet. Natural question arises, sir, if size is more than the 1024, so how? No, not a single tick packet is out. Now it will take 2 tick to send the data more than the 1024. So after 2 tick, there is a data byte 1024, more than the 1024. So in this way, we can work. This is the flow chart. We fix the, we count, initialize the count. This is so that we initialize the count, and initial amount of the data can be sent in the one tick. It will be the packet one or the size. Initialize means, here in the previous example I took it, 1024 is the size, initialize. If size is less than or equal to the value of the counter, the packet is sent and the counter is decremented by the packet size. This step is repeated until the n is smaller than the packet size. When the size of the packet is greater than the value of the m, the packet is left in the queue and wait for the next click on that. I earlier told you that if the size of the 1024 is suppose 110, then so what we do? We wait for the second tick, because in the 2 tick it will go out. Okay. So these are the concept in the beginning. And there are some problem also. What is the problem? Problem is like this ideal time. Why? Problem lie in between this ideal time, because data is coming out, because source is ideal for some time, but it is not useful for source, because the concept, the water is coming out the constant rate. So what happens? If it is ideal, it may be after ideal it will get the more heavy volume packet. But that heavy volume packet is not, suppose we are sending the 5 packet out, but first we have getting the 4 packet, ideal for them. The next time that packet 10-20 packets is come, but the limit of the packet outflow is limited. Then nothing, and for being an ideal, it is not helpful, and it is a gap. It will the packet will be waiting time will be wait to out the packet. So using this gap ideal problem, and there is a solution for that, is token bus. I take the example, if the host ideal, you can say the leaky bucket algorithm only average constant rate data flow. Major problem is the cannot ideal with breasty data. If host is ideal for 10 seconds, now it is willing to send the data at a very high speed, another 10 seconds. Total data transmission divided into the 20 seconds. Average rate will be maintained and the host no advantage to sitting idle for the test. Ultimately, there is a delay. Because output of the bucket is constant. So that is the problem. Overcome this problem is total bucket algorithm. To coin bucket algorithm allow breasty data transfer. Then token bucket algorithm modify of leaky bucket in which the leaky bucket contains the token. So how we can say this? Now to understand that every packet is attached a token. Every packet is attached a token. And first come first, one token is out, packet is out. So you can understand if there is a 5 token containing the 5 tokens and we received 3 packet. So how much the data is out? 3 token out, 3 packet out. So how many token is remaining? 2 token is remaining. When 2 packet is come, then there 2 packet is. So total 7 packet transmitted. So how it's work? How it's work? Its work basically, you can understand that packet that capture the token are and got through. It is necessary the packet which have the token will only that packet will be going. So it means this bucket we are adding the token. So now understand thing. When the you can understand that if there is a 4 packet token here and all the 4 packet are here, so they are transferred, but these 2 packet have to be wait until that 2 tokens are coming in. When 2 tokens are coming in, these 2 packets are transferred. So it means it is understand that in order to get transmit, each packet capture and destroy 1 token. When the flow go through out, then that token is destroyed. So following so what we have seen now so we have so 5 out of the 7 packet have gotten through, but other 2 are left. Still stuck waiting for the 2 more token are generated. It means in principle we can say every token, every packet is out from the bucket when it have the valid token. So what is the advantage? Well, that is the ideal frame. If source is ideal, to try to understand thing, when the source is ideal, then this bucket are adding the token. Still adding the token. It means if source is ideal and we added the 10 more token to it, so when after idleness, when this source send to the 10 packet, immediately these 10 packet have the token because there is a ideal 10 bucket already at the token 2 is the 10, which are unused. So because that after idealness, when who send the 10 best 10 token, then 10 packet, then immediately this is passed on from the bucket. In this way, this bucket. So this idealness, because due to the idealness, the source is still in the waiting state. But now in this case, because token already there, after ideal, the source provided the packet is not waiting. It is again sending the their packet, but immediately sending out from the packet. So these two algorithms work. So now in this lecture, we have studied the leaky bucket and token bucket. Hope so you understand the concept. Thank you so much.